Hello friends, welcome to your very own channel sonisinghphysics. In this video, I am going to discuss about electricity and magnetism, and this video is part 1 of this section. Here I have taken the questions where students find it quite difficult to respond, especially with the directions of current, force and magnetic field. So here is the first question. The diagram shows an electromagnet near a coil of wire connected to a voltmeter. The reading on the voltmeter is 0. The switch is closed. The electromagnet magnetizes quickly. What happens to the reading on the voltmeter? So the correct answer is it quickly increases and then decreases. So let's see the reason why it will be like this. The induced voltage is produced as a product of electromagnetic induction. Once the switch is closed, electromagnet produces magnetic field and this field gets interacted with the electric field of coil. The moment the switch is closed, interaction will be high, so induced voltage will be high, but after a moment when the current becomes steady, this interaction will stop and then induced voltage will decrease. So in that way, voltage will increase in the beginning and then it will decrease. The diagram shows a coil of wire wrapped around a soft iron rod. The wire is connected to a DC power supply as indicated. The apparatus is in a region which is totally shielded from the Earth's magnetic field. So in this setup, there is no effect of Earth's magnetic field. The question is, a small compass needle is placed at a point P, as you can see here. In which direction does the north pole of the compass needle pointed? So here the answer is towards the right of the page. So answer is C. Why we will see here. This question is based on right hand grip rule, and this is right hand grip rule. As per this rule, curling finger shows the direction of current and thumb shows the direction of north pole. This is the explanation. Here current enters from left side of the coil, so as per right hand grip rule, left side of the core will become north and other side will be south. Magnetic field direction outside the core will be from north to south, as you can see in this picture also. Then what will happen? Compass point itself in the direction of external magnetic field. That's why compass will point towards right of the page. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid while the rod is moving. Which rod is being inserted? So these are the 4 options: a heated copper rod, a magnetized steel rod, an uncharged nylon rod and a radioactive uranium rod. So here the correct answer will be a magnetized steel rod, because that will only have effect on the ammeter. Others will not have any effect. Next is, the diagram shows a wire carrying a current in the direction shown. The wire is between the poles of a magnet. A force is produced on the wire out of the page. So here you can see this is the direction of wire out of the page and direction of current you can see here. The wire and a magnet are now put into different arrangements X, Y and Z. The arrow shows the direction in the current in each case. In which arrangement is the force on the wire out of the page? So here we have to see that where the force will be out of the page, and the correct answer is Z, means answer D, but we will see how and why. This question is based on Fleming's left hand rule, and as per this rule, first finger pointing to the direction of field, second finger shows direction of current and thumb shows the direction of thrust. Now we will see what is the meaning of direction into the page, out of the page and down or up. In this, direction of current is down to the page and here current is up to the page. This is the question arrangement: current down to the page, field direction and force out of the page, and this is the arrangement Z, field direction reversed, current out of the page and force still out of the page. The diagram shows a wire between 2 magnets. An electromotive force is induced in the wire when it is moved up between the 2 magnets. 4 tests are done. The direction of movement of the wire is reversed. The direction of the magnetic field is reversed. The wire is moved more quickly. The magnetic field strength is decreased. Which test will induce a smaller EMF in the wire? So here the correct answer will be D, that is the magnetic field strength is decreased. So now we will see what are the factors which affect the production of EMF, and these are the 4 factors: the number of turns in a coil, the speed at which the conductor moves through the magnetic field, the length of the conductor, the rate at which conductor cuts the magnetic field lines, and strength of magnetic field. So when we change any one of them, then definitely the amount of EMF will get affected. As you can see here, induced EMF is maximum when conductor is intersect magnetic field lines at 90 degree, and EMF is 0 when conductor moves parallel to the field lines. In this question, 4 positions of a current carrying coil in a magnetic field as in a DC motor as shown in diagram 2 and 4. The coil is at an angle of 45 degree to the field lines. Which row is correct? So now if you have understood the previous concept, you can easily answer this question, and answer is B. That is position 1 and 3 is different, whereas position 2 and 4 are same. I hope this video will be helpful for you, and if you have any question, you can text me. I will get back to you very soon. Thank you for watching to your very own channel Sonisinghphysics. Please do like, subscribe and share. Thank you.